Consider this. You are not standing still. The ground beneath you rotates at over 1,000 kilometers per hour. The planet races around a star at 30 kilometers every second. That star orbits the center of a galaxy containing 400 billion other stars, a galaxy moving at over 2 million kilometers per hour. And the direction of that motion? It is not random. If you could watch the Milky Way from outside, you would see it cutting through intergalactic space at 600 kilometers every second. 2 million kilometers per hour. At this speed, we cross the distance to the moon in just over 10 minutes. But we are not alone. Every galaxy in our cosmic neighborhood moves with us, following a course we never chose. The question that haunted astronomers was simple. Why? Every star in the night sky, every galaxy within 200 million light-years, is drifting toward the same point in space, a point we cannot see, a point we do not understand. The source of this motion has a name, the Great Attractor. But that is not the answer. It is only the beginning. For most of the 20th century, astronomy told a simple story. In the 1920s, Edwin Hubble discovered that galaxies were receding from one another, not moving through space, but carried by the expansion of space itself. The farther a galaxy, the faster it recedes. It was a perfect pattern, but perfect patterns in nature are rare. As measurements improved, astronomers noticed deviations. Some galaxies were not receding as expected. They were moving against the expansion, or perpendicular to it. These unexplained motions were called peculiar velocities. They were supposed to be minor. They were not. The first clues came from radio astronomy. In the 1970s, astronomers measured the cosmic microwave background, the faint afterglow of the Big Bang. They expected uniform radiation in all directions. Instead, they found asymmetry. One side of the sky was slightly warmer, the opposite side, slightly cooler. The entire solar system was moving through the radiation field at 600 kilometers per second toward the same region of the sky. Something was out there, and we were heading straight toward it. In the 1970s, astronomers mapped the motions of nearby galaxies with unprecedented precision. They expected scatter. They found order. Hundreds of galaxies, then thousands, then hundreds of thousands, all moving toward the same region of the sky, not drifting, not meandering, falling. The local group, the Virgo cluster, the entire Hydra Centaurus supercluster, all converging on a single point 600 million light-years away. The galaxies were responding to something powerful enough to overcome the expansion of the universe itself. Astronomers called it the Great Attractor, but they could not see it. The Great Attractor lay behind the Milky Way. Our galaxy is a flat disk, and from our position inside it, the disk appears as a dense band of stars, gas, and dust stretching across the sky. This band, the galactic plane, blocks nearly half the universe from optical view. Astronomers call it the Zone of Avoidance, the blind spot of astronomy. Without an image, astronomers worked backwards. They calculated the gravitational force required to pull hundreds of thousands of galaxies off their paths. The result suggested a mass equivalent to tens of thousands of galaxies, an object so dense it should have been easily visible. Yet the sky remained dark. Either the Great Attractor was made of something that did not emit light, or astronomers had fundamentally misunderstood its scale. Both possibilities were unsettling. For years, the Great Attractor remained a ghost. Astronomers could measure its gravitational signature. They could calculate its mass, but they could not image it. Like hearing thunder and knowing the storm is there, but the sky remains clear. By the 1990s, infrared and X-ray telescopes pierced the zone of avoidance. Dust does not block these wavelengths. For the first time, astronomers saw what lay behind the veil. Dozens of galaxy clusters, hundreds of galaxies. The Norma Cluster at the center, with a mass equivalent to 10,000 galaxies, the Great Attractor, had been found. But even the Norma Cluster's mass fell short of what should be required to produce the observed motion. The total visible mass was not enough. To explain the pull, the Great Attractor must contain vast amounts of dark matter, invisible but gravitationally influential. The Great Attractor was not only hidden by dust, it was hidden by the nature of the universe itself. But it was not the final revelation. In 2014, a team led by Brent Tully mapped the motions of more than 100,000 galaxies. The result was a map unlike any before it. The Milky Way, the Great Attractor, and nearly 100,000 other galaxies were all part of a single structure spanning 500 million light-years, a cosmic basin of unimaginable scale. They named it Laniakea, Hawaiian for immense heaven, one of the largest structures ever identified. And yet, it was not the end. Beyond our supercluster, astronomers identified the Great Attractor Wall, an immense sheet of galaxies and dark matter stretching across billions of light-years. It connects the Great Attractor to the Shapley Supercluster and beyond, forming part of the cosmic web. Our galaxy is following the curvature of the universe itself, tracing the contours of space as gravity warps it. But the flow within Laniakea was not uniform. Galaxies near its edge did not move as expected. Something beyond the supercluster was exerting influence. Astronomers looked further. They found the Shapley Supercluster, 8,000 galaxies, a mass of 10 million billion suns, located 650 million light-years away. Its gravitational reach extends across hundreds of millions of light-years. The Great Attractor is responding to something far larger. The Shapley Supercluster is pulling the Great Attractor and everything within it. The Great Attractor is not the destination, it is a waypoint. Which leads to a profound realization. If the Great Attractor is only a waypoint, our motion continues toward Shapley, and Shapley itself may respond to even larger structures, so distant their light has not yet reached us. Where does this chain end? Is there a final destination? Or are we part of an endless cascade of gravitational currents carried from one cosmic basin to the next? Cosmology does not yet have an answer. Every discovery in cosmology reveals the same uncomfortable truth. We are not observers standing outside the universe. We are participants, carried by forces we cannot see, moving toward destinations we cannot name. Right now, Earth orbits the Sun. The Sun orbits the galaxy. The galaxy falls through the local group, and the local group accelerates toward a point 600 million light-years away, at 600 kilometers per second. We do not feel it. We never will. But it is happening. The Great Attractor is not the end of the mystery. It is the threshold. Each new survey reveals deeper currents, larger structures, questions that did not exist a generation ago. The Great Attractor was once the ultimate source. Then we discovered Laniakea, then Shapley, and beyond Shapley, structures dwarf everything previously mapped. The universe is not a collection of isolated objects, but a single interconnected system. What we call the Great Attractor is simply one node in this vast network. Somewhere beyond the edge of our maps, gravity continues its work, pulling, shaping, carrying us on a journey that began long before humanity existed. The universe does not need us to notice, but once you do, the night sky is never the same. Because the stars are not fixed. They never were. And somewhere, 600 million light-years away, something is pulling us right now.